Welcome to Hot Chips 26. Keynote 2, The Future of Wireless Networking.
Hi, my name is Behnam Robatmili from Qualcomm Research. I'm happy to introduce the keynote speaker today. Rob Chandhok is the president of Qualcomm Interactive Platforms and the senior vice president of Qualcomm Technologies Incorporated. In his current role, he is responsible for actually the product and strategies across the company that helps people use Internet of Everything. So he oversees a couple of important platforms in the company, including all-join IoE ecosystem, vision-based computing, and, and wearable computing, such as Qualcomm smartwatches, named Talk. He also leads the company internet services, such as voice-over IP solutions for mobile operators. Prior to joining Qualcomm in 1993, he founded a company named Within Technologies, which focused on computer-mediated communication systems, and that company was acquired by Qualcomm in 2000. He started his career as a research computer scientist in the Department of Computer Sciences in Carnegie Mellon University, and was there for over 10 years. And he published in the areas like programming systems. He had 30 patents and has a bachelor degree from CMU in electrical engineering. With this introduction, let's welcome the speaker.
Thanks. Good afternoon. So I find myself again, I just got back from speaking in China, and I was also the right after lunch speaker there at TechCrunch in Beijing. Only you guys are much more prompt than they were. So first of all, thanks for inviting me here. I have to admit, when the conference organizers first asked me if I wanted to speak at Hot Chips, I did say, are you sure you want me to speak at Hot Chips? Because I'm the software guy at the hardware company. So what I'm going to talk about actually is, it's related to what we do in the silicon at Qualcomm, and I'm going to talk through a little bit of the sort of the breadth of how we think about the Internet of Things or the Internet of Everything at Qualcomm. And then as we get towards the end of the talk, I'm going to intersperse with the discussion about an approach that we've taken for thinking about the protocol at the edge of the network that I think is going to be important to the Internet of Things. I'm going to talk about a technology proposal we have, and I'm going to try to also put in there some of the design rationale for why we did what we did. And I'm going to leave time at the end for Q&A, and I would encourage folks to actually make this interactive. So I'm going to actually hoping to leave 15 or 20 minutes at the end, because I think given what was discussed at the lunch table, it could be a really lively and interactive thing. I think the other thing is that this topic, Internet of Things, Internet of Everything, is so overloaded right now. I think the only way you can kind of tease out the design parameters that could be important not only to what we do in the software layers, but what we do in radio and the physical implementations on chips, how we package, what we package, how we do system partitioning. I think that discussion has to go on for a while, and I don't think that, I certainly don't know anybody that I think I could walk to and say, that person understands the whole problem and can define that. And just this morning I was noticing, I don't know if people heard of this app that was sort of a buzz for a while called Yo, which it only does one thing. It sends a yo to another person's phone. Don't laugh. They raised $1 million. I don't know what the post was on the round. And now they're recasting themselves as an Internet of Things company. And if you follow me on Twitter, you can see my surprise on that. So just like before, for a while, they're putting wireless at the end of something or putting web at the end of something, sort of made people think that they could fund it or get VC funding for it, or it was something new. I'm doing bread, but for the Internet of Things. I think we're sort of at that stage of hype where everybody's talking about it. I hope by the end of this talk, you'll at least have a little bit of an understanding of the parameters that I think are important to think about for the Internet of Things, how wide the problem is, and then maybe at the end you'll also agree with me that I think the Internet of Things vocabulary is really the way what we're talking about now to really talk about the next phase of the Internet, right? I think in 5 years we won't talk about the Internet of Things because we'll just be back to talking about the Internet. There'll just be 100 billion more devices connected to it, right? So let's wade through some marketing. So you probably know who Qualcomm is. We're pretty good in semiconductors, especially wireless semiconductors. Lots of chips going out. We use bees after the shipments, and it's pretty exciting to be there. I started at Qualcomm actually working on an email program called Eudora, for those of you that remember that, and actually went through all the way to the point where I was doing running engineering organizations that did chips and radios and so forth. A lot of what comes from mobile, and a lot of what we've had to think about in mobile ecosystems, what we put into the mobile phones as they're coming out and how fast that technology is going, I think actually is going to be very applicable as we push things further and further to the edge of the network. So the kinds of things that we do and we apply our mobile technologies to, the kinds of domains, I think that you're going to see some of the learnings that we did there, how we thought about video compression differently than the large screen TV guys thought about it, or how we thought about how you might use radios for microlocation to do things like retail. Those kinds of things are getting used, some of the same technologies are getting repackaged in new ways now as we move forward. Depending on who you talk to and who sizes the market, you get sort of a wide variety of how people think the Internet of Things is going to change in terms of the number of connected devices. It certainly is, I think, a consensus that the vast majority of these devices are going to be smaller at the edges of the network, probably, but many, many more of them. One of the analysts that we use in our slides quotes 25 billion. They're friends that I have at a consulting. Whoa, I didn't know that was going to change. That actually put out a book called Trillions. And if you're actually interested in a broader discussion about what might be happening, it's a really cool book from Maya Designs, the principals at Maya Designs in Pittsburgh. But regardless, the way, the shape, the topology, all these things about the Internet are going to change because of the new challenges for scalability that are going to come with these increases in numbers. So whether I'm talking about adding 10 billion more devices or I'm talking about adding 100 billion devices, it doesn't really matter at this point because a lot of the systems that we have designed don't scale to either of those numbers. So we have to think about architectures and topologies quite differently. Another thing that we really see the path to, and I hinted at this before, is that we're going to be able to apply these learnings from mobile technology towards the Internet of Everything. This slide, we're actually trying to point out a little bit about the difference between permanently connected and intermittently connected. Around about the time people were first starting to put packet data into cell phones, and I think this really happened in earnest, in the early 2000s. There's a lot of work thinking about on the IP routing side of how they were going to have to change the routing protocols to accommodate this new kind of mobility. Before IP had really been set out, that once you set up a network and you sort of got a relatively fixed topology, those changes didn't have to propagate very fast. And all of a sudden, I had to be able to handle not only devices or nodes on the Internet that could be driving down the road at 60 or 70 miles an hour, but that could get on a plane and pop up somewhere else on the other side of the country. And there are all these proposals for doing mobile IP. I don't know if there are folks in this room that probably remember that we're going to anchor things so that you would have an IP address that didn't change, but it would follow you around the world, much like your phone number follows you around the world. Well, one of the things that we all learned actually quite quickly when we're writing apps on these new kinds of connected devices is the only thing that you actually had to handle was your IP address changing. Once you handled that, you're actually okay. I didn't need this big change to the core network that would change it. I just had to think about how I connected to the Internet differently. a lot of devices that we're going to see on the Internet of Things aren't things that are going to be streaming or always connected or permanently homed on the Internet. In fact, my belief is that a large number of the devices that we think of as the Internet of Things are actually not going to be on the publicly routed Internet anyway. I think they're actually going to be connected, but they may be connected locally and get services through well-defined gateway services back to the capital I Internet. I think you do that for security. I think you do that for privacy. But most importantly, you'll probably do it for power at first, right? You can't be that first-class citizen on the Internet and go to sleep for an hour, right? Because you might need to actually respond to something from a service that's out there. So that kind of thinking, I think, not only drives how we think about new kinds of radios, and there's been some really interesting twists on that happening, Google and ARM and a bunch of other folks talking about the Thread protocol, which is in an unlicensed 15.4 band. But thinking about how we run that all the way up to the IP services layer and how not only our radios talk to each other, but how do the equivalent of web services or internet services talk to each other in this new topology, in these new areas. So we're going to have to think about something more than HTTP as we get into the Internet of Things. And I'm going to say that probably about 20 more times during the next 40 minutes, so hopefully it won't bore you too much. Let's go a little bit through really high level, and I'm not going to go into a great deal about any of these, but just to spur a context here, because I often get concerned that when we're talking about Internet of Things or Internet of Everything, and I will caveat me saying those two things all the time together, because I actually like saying Internet of Things, because the sort of academic in me, when I hear the phrase Internet of Everything, I just reduce it to Internet, because that's what the Internet is to me. The Internet is, by definition, everything that's connected to it. So I'll probably just say Internet of Things from now on. My marketing people will not like that. Connecting smart cities. There's a lot of things right now that are already going on with how cities are trying to exploit connectivity and connected services in order to either increase performance, lower costs, offer services they weren't able to offer before. And you're starting to see that be a theme over and over again. Global companies like Cisco and IBM are driving a lot of these kinds of transitions. There's been a lot of really interesting stuff happening. So when we talk about the Internet of Things, sometimes the things can be quite big and sometimes the things can be quite small, but it's not the same as just connecting an internet client, right? There are things that may have autonomous intelligence, and there may be things that may act intelligently when connected in a mesh or in a web or in some other topology. So when I think of how a city might tie together, for example, its traffic light system, they might use IP, but they have to design a system. They probably won't put DNS addresses for every traffic light, for example. They'll probably think about that system differently so that you can go and add a traffic light or take one away without a lot of centralized control. Because over time, as these devices get more and more complex, that kind of centralized management doesn't scale. So there's some interesting things going on there. Even something as simple as transportation, and this is one facet of automotive, and I'll talk a little bit more about some others. Let's just start with the base case. What if your car were actually on the Internet all the time or had the capability to connect to the Internet all the time? So rather than, I have an old enough car that I have some services, but they do it basically by a dial-up modem, right, over an analog radio. What if instead I had a 4G radio in there and I could actually, if I wanted to, have my car be a hotspot for all the people that were in it? Just having that kind of connectivity changes a lot of what you do on the consumer, or what they, in automotive industry, call the infotainment side of the world. And it's happening very, very quickly, right? I mean, the numbers, 2017, 60% of the cars shipping are going to actually have the capability to be connected to the Internet. And the carriers are thinking differently about that, right? AT&T, for example, is sort of leading the way in packaging a lot of services up. So if you have already service from them, adding another device like your car is going to be incremental rather than be a doubling, for example. And Verizon, Sprint, those guys are all going along. A lot of analysts are predicting that in the home, there are going to be doublings of the number of connected devices. I actually think that's a little bit conservative as we move, because I think lighting is going to actually happen faster than a lot of people think, and I'll talk about that a little bit later. But I think that even if you look at doubling the number of connected devices on the broad mass market, that can be a lot of devices. Wearables. So I'm wearing one of those watches. So Qualcomm did a little experimental watch. We are not a consumer electronics company, but we were playing around with what would it be like to have an always-on display. So that's a MEMS-based display technology called Mirasol. That's a Qualcomm technology. And we actually put out a watch last September that tethered to Android phones and did things like you could curate your notifications list onto your wrist. So in addition to just seeing things like SMS or who's calling you, I happen to use WhatsApp with my family, so I can get WhatsApp messages on my wrist if I so choose. And it turns out to be a lot more useful than even I thought it was going to be. And since then, you've seen a bunch of things launched. Pebble was around before that. Pebble does a lot of those things and more. And Google has announced Android Wear. But the idea that some of the things that are going to be connected are not just going to be small things that are in the environment around us, but they're also going to be things that are on our body, right? And that technology also very hot. Also, if you want to get funded, putting wearables, if you put wearables and IoT, everybody gets really excited. Wearables are actually kind of interesting because they pose a set of different problems than even the Internet of Things in a car or a home, because the wearable thing for me is really interesting because because it's on your body, it's that ultimate mobility. So we're already doing a lot of those things with phones, but even when I put my phone down, I might have several other things on my devices that could technically be either connected, sensing, or doing things. There's a lot of interesting work to be done there about the silicon involved, what we're going to do to both drive devices smaller so you can change form factors. A lot of what drove the design of this watch was that's the battery there, and you'll see a lot of other designs that are driven by power rather than by just any other facet of the design. Last week, Timex announced a watch using this same display, but interestingly enough, with a cellular radio in it. So it's basically got a feature phone chipset inside of it, and it's specially designed for fitness, so it's an Ironman brand watch. And the idea was that most people carry their phones with them when they run because they want to be able to call somebody if they get hurt, especially if you're a distance runner. Well, if this phone can send emergency messages, receive and send simple messages, then all of a sudden you don't have to carry your phone with you, especially if you have the music. So Timex actually launched that. If you look at that watch compared to this one, it's a lot bigger. Why is it bigger? Mostly battery, because the peak current that you need to drive a cellular connection is quite different than the peak current that you need to drive a Bluetooth connection, right? So we're still thinking about, a lot of people are focusing on how am I going to get the power on this chip, or how am I going to shrink the form factor of the chip, and we have to actually think about the whole system when we're designing it. But there's a lot of interesting stuff happening in wearables too. So I think it's also important to think about the way that some of this is being driven is by sort of fast advances in how we are connecting things. So the cellular networks and the Wi-Fi networks that have been out there and sort of been filling interesting gaps are starting to actually overlap in both some of the architectural aspects and certainly are available in many of the same devices. So we're seeing, for example, increases in bandwidth made available by what we call small cells, so shrinking the size of the cells even in cellular technologies so that you can basically get closer to that optimal configuration of for every device that wants to use a radio to connect to the internet, you have one base station serving it, right? So if the smaller the cells get, the closer that you get to that kind of ideal. So we're thinking about all of those things together as we try to move towards the Internet of Things, because some of them will want this sort of mobile connectivity to the macro network. We think the combination of that kind of connectivity plus sensing and a coordination of that sensing means that you can actually get some interesting things coming out of the spaces that you get into. So we've been starting to work with a lot of places like stadiums, museums and parks, transportation systems that use this connectivity and sensing to actually provide services back. So Disney at a theme park might tell you, this ride doesn't have a very long line, you can actually go over here, right? And you start to change the experience based on sensing, connectivity, and distributed intelligence in the systems. Do you call that Internet of Things? I think some people would argue that that's Internet of Things. Some people would argue that it's just another new kind of system. But I think at the edges of them, you're using a lot of the same technology. So I kind of lump it in there too. Infrastructure is changing, I think, in a lot of ways with connectivity. So I can say, okay, we put connectivity in a car, and all of a sudden I can get traffic reports while I'm sitting in the car, and I can run other kinds of applications. But what if my car started talking to the car behind me, the car in front of me about traffic, if it started talking to the traffic systems, if route planning was integrated with the traffic systems that were actually driving the lights in a city, right? You could actually see ways of actually generating more optimal behavior if you knew more about the intent of what people are doing, right? So there's a lot of really interesting work going on there that at one edge, which I think is very difficult, sort of borders on some of the safety applications. There are people that are trying to build systems that sense pedestrians and avoid accidents, all the way to things like I saw somebody demonstrate a system that does a different kind of way of managing miles per gallon by actually getting cars to line up a certain distance so they can all draft off of a truck. But this one system, which is in Europe, actually did it by saying that the lead car of that train was going to be a specially trained driver. So you would basically be saying, I'm going to put an extremely safe vehicle in the front, and I'm going to basically caravan, like a train almost, on a public highway, 15 to 20 cars behind it. And they all get better mileage, and they're probably all safer because their automatic systems are maintaining right distance. And since they're connected, if that smart driver brakes up front, all the cars brake evenly. Now, that's an interesting way I thought of taking that smart transportation, using some of the infrastructure, but doing it in steps that make it sort of plausible to believe that we're going to get to a place where we're going to have intelligent systems like that. We have 2 of these slides, so I'm going to go to the next one. You don't need to see the brands. So we're thinking about a lot of different things inside of the car beyond the connectivity. We're trying to think of what ways can wireless technology help drive cost and other kinds of savings out of the car. What if some of the wiring harness in the car could be replaced by wireless technology, for example? What if there were interfaces that smartphones could use to talk to the systems of the car so that if I wanted to augment the behavior of my vehicle in the future, I could do that by downloading an app onto my smartphone, right? So I'm going to talk about that technology. That's the first mention of AllJoyn, which is the protocol that I've been hinting at. The idea being that a way of building these kinds of Internet of Things, and maybe one way that I try to think about the Internet of Things, is actually as a set of cooperating entities that speak using a common protocol. And the analogy that I try to draw for that is the ecosystem that exists on the web side of the world. When HTTP and HTML came out, you could argue that a lot of people, what they see the effect of that was on the consumer side. So because of the web, we were able to drive consumer systems to a certain way. We were able to be able to launch a service globally just by putting up a web page. All this really great stuff happened because of Mosaic, which turned into Netscape, and then all the browser environments that we have now. The other side of that, the more invisible side, and to some degree I would argue one of the possibly more important side, was the business-to-business connections that happened through web APIs. So if I wanted to put a map on my web page or get an advertisement or get a service about something about the person that I was talking to, I could use HTTP for that as well. And there's a huge multi-billion, hundreds of billions of dollars ecosystem built up around that. I think as we get to the place where you can interact with cars and cities and things around us, we're going to see that same kind of ecosystem. So one of the questions I think about, especially in a technology context, is how do we partition our systems correctly so that people can put them together in interesting ways that we can't actually foresee right now? And that partitioning will both be at the hardware level and at the software level. A lot of times, Internet of Things discussions degenerate into a conversation about home automation. So I'm going to put up connected home slides, but I don't want you to think that that's what this is all about. It just happens to be a very tangible example because there's starting to be people nibbling at the edges of what it might be to have this kind of connectivity, only right now they're sort of doing it in a very vertical way. The president of Qualcomm Atheros, which is our connectivity division, Amir Feintok was walking around CES this year, and he made the remark that I thought was very telling. He says, you know, I've seen a lot of stuff out there. I'm not really seeing the Internet of Things. I'm seeing the Internet of Thing, right? What you get a lot of the time is you get somebody who builds a connected thing, and that thing usually punches a hole through to a server somewhere and then talks to a smartphone app. So if I want 2 things, then I have 2 apps. And I want 3 things, and so forth. You get the pattern. That isn't going to scale over time, right? It'd be like, you know, so that whole app ecosystem doesn't really work well for an environment where I might have hundreds of these things around, or hundreds of things that I want to talk, probably thousands. So it's something to think about, is that we're at that stage right now where people, partly because it's much easier to build hardware these days than it used to be, right? And partly because cloud services are so easy. I can just go to AWS, turn on a service like that, and build an app, and it's all pretty straightforward. In fact, there are companies that will host that whole ecosystem for me. That's easier than trying to solve the same problem that Tim Berners-Lee and Mark Andreessen did when they thought about the web, and a host of other people. I'm not trying to trivialize how HTTP and HTML came about. So let's get back to the connected home then. So keep that in mind as we go through this part of it, and use that maybe to think of really hard questions to ask me at the end when I try to propose something that might work. So we're already looking at a lot of things in the connected smart home, although how the home itself gets smart is kind of interesting. I think right now a lot of people assume intelligence is going to come from sort of centralized asset. I happen to think that intelligence is going to be distributed throughout the system. And I think one of the things that's going to happen in the Internet of Things is we're going to start to see smart things interacting with other smart things, right? The same way we see intelligent services starting to interact with other intelligent services on the web. We assume that right now, because the compute is easier to access in the cloud, that's the way it's going to be. But I guarantee you this intelligence is going to push out to the edges, because you won't be able to do these experiences any other way. So we're already seeing people do things like, you know, the classic one everybody thinks about is the thermostat, right? And the Nest thermostat. And it has both a machine learning component to it, and it has a control component to it. It was a very straightforward thing. There's a way that we all talk about thermostats. There are wiring standards for it. And now you can see that is being used as a gateway into talking to other things around there. Other folks have come at this from other angles. There's a lot of people that are using smartphones to control things. Appliance manufacturers are starting to add cloud services for their refrigerators and their washing machines, so that a thing that didn't have the ability to have a user interface could now has an interface. And I think that's a really interesting thing to think about. If I have computing in more and more things, so take, for example, I have an instantaneous water heater at my house. It has a pretty powerful microcontroller on it, actually, because it's doing a lot of things. You open it up, you can see all the things that thing is controlling in order to most optimally generate hot water. And there are probably some things that I could tell it about the way our household uses water. But that manufacturer didn't want to put a touch screen or a keyboard or anything else in there. Imagine if they just put connectivity and there were standard protocols for thinking about it, and you could have systems that talk to each other, or you could just more simply expose a UI to something that had no user interface elements. So you're going to start to see, I think, a lot of that stuff happen about. And that's going to come partially because we will use it with devices that don't worry about power because they're plugged into the wall. Some things are going to really care about power, and you're going to see developments in low-power compute and radio that are going to be combined to do really interesting things. You know, the sort of the Zigbee, Z-Wave, Bluetooth of today is going to be replaced probably by low-power Wi-Fi, and the compute availability is going to go up as we get more and more power efficient and these radios get better. So the smartphone is sort of really a good aggregation, and it follows a similar pattern. When we started with phones were sort of just phones, and then we threw cameras in, and then we threw other sensors in, and then people used all those components to create experiences. And I think we're at the very beginnings of that in the connected home. One of the other things I think we'll see sort of anecdotally is as we connect a lot of things around the home, in particular media is going to drive a different set of requirements than the ones I just described. So some people focus on the Internet of Things being just about low power, you know, things. They think about control, command and control. There will also be media components, so it's important to imagine systems where you blend all kinds of those experiences, right? Much the same as the web is a different place now that we watch video in the browser than it was when you had to actually go get a file or download it or stream from a special thing, and there were 5 different types of applications that you use to stream video, right? That kind of interoperability driven by basically people wanting to drive new experiences will drive us to do new radios and also integrate new kinds of technology. An example of how one of the ways we're responding to that is we're starting to put together systems that can blend the networking and the compute. So one of the first things we have in a gateway platform is we actually have a high-power compute processor, the IPQ processors, which are based on our high-end mobile processors, combined with really good switching fabrics. And we can put things like intelligent packet switches like Stream Boost on there that can do curating of application streams so that you can say, give priority to real-time streams versus others. We're putting things like all-join, which I'm going to talk a little bit about, and we're making it so you can put new services on these platforms. So from a silicon perspective, you've got an interesting architecture. We've sort of brought together what used to be thought of as a networking processor and more of a core CPU, and we're actually doing it all on one die, and we're getting some really interesting software environments to layer on top of that. So I think that could end up driving some interesting things that will both be sort of home gateway kind of architectures, but also architectures that might replicate themselves throughout the house for different uses. Let me talk a second about what we call the digital sixth sense, just to give a little context. Excuse me. When I said before, when I was talking about the interest in sort of wearables and things that were on your body, I really think that proximity is also one of the hallmarks when you're thinking about the Internet of Things. That it's important in the sense that proximity will start to matter in the experiences more than what we sort of classically associate with the Internet, which is virtualization. We spent a lot of time over the last 20 years making it so you could interact with something without caring about where it is in the globe. And that's really cool. Turns out there are a bunch of things that you want to interact with because you're in the same room with them, right? Proximity actually can matter. Otherwise we end up building systems that don't match how we behave socially or otherwise will appear awkward, or frankly we won't be able to grow into experiences we want. Sometimes I think about it as when I'm doing things that are proximal, instead of thinking about my location as a latitude and longitude, I think of my location as more of a polar coordinate system where I'm always 0, 0. And then there are things around me in that polar coordinate system that I can use, and I can use that information to drive experiences, but it's going to be important to me how I sense that. Now, what I do with those things, how I sense them, the permissions that I have for them, may be based on proximity, may be based on the rights and privileges, but I might be able to do things because I'm near something that's the only reason that I get to do them. So I use the example of one of my kids' friends gets into my car and they want to stream a song to the speakers in the car, right? Well, I don't really want to pair this kid's phone to my head into my car because I might never see this kid again. What I want is, because I let them into my car, I want them to have permission to wirelessly stream to the head-end unit of the car. Because if I don't like what they're doing, I can kick them out of the car, right? That's the social convention that we have. Well, it turns out radios can't exactly do what we're talking about. I probably would use audio and maybe other sensing technologies. But if I built that correctly and there was a common open communications framework, then other people could build experiences like that said, if you're in the same room as me, you get this privilege. And the car being an example of a room in that case. If you're in a meeting room, you can wirelessly project to the projector. Because if I'm doing a presentation and you start shoving your slides over mine, I'm probably going to be able to fix this. I might not do that in an auditorium where I'm with people that I don't know. But if I'm in a 10-person room, why do I have to have passwords and privileges and other kinds of things in order to be able to do something that is the same as plugging a cable in, right? It's the same social convention. So proximity and sensing, I think, are going to be something that is going to be used and layered on top of these new communication frameworks that we're going to build for the Internet of Things. And I think that it's that combination that's going to drive interesting experiences, much the same as when we had the mobile Internet. The big difference was you had a connection to the Internet and you had a latitude and longitude, right? I remember in early 2000s, we were first trying to build systems that when you started to do a search, and there wasn't Yelp back then, but say you were looking for a restaurant, And just knowing the city you were in could save you a lot of typing, right? And that was revolutionary at that point in time, right? And so now we're talking about really sort of these micro-location kinds of things and other things from the environment that can help anticipate and build new experiences. So I think that interconnectivity, we have to think about connections, connectivity, privilege, access, security in a different way than maybe we've thought about it before, right? It can't all be based on I need to put the same security on certain things as I would for changing the passwords for the university's computers. All right. So sensing that could be motion or other kinds of sensing, things about the environment. Cameras, I think, are getting more and more important. So one of the other projects that is in one of my divisions is Vuforia, which is a virtual reality and augmentation platform. And there, what a lot of people think we're doing is trying to just make cool things pop up on the screen when you point at a target. But really, it's the beginnings of letting the smartphone or the computer see, right? And if they can see and sense and discover, then we can use that as part of a larger system to build an experience, right? One of the things I'd like to be able to do, if I have a digital picture frame, I'd like to be able to point at the picture frame and say, throw this picture onto that one, not the one that's over here. And there's a multitude of technology I can do that. We've built systems where you use the camera to actually detect that, right? So there's a lot of interesting stuff going on in that area with virtual reality and augmentation, especially around heads-up displays right now. But they're going to get combined with these other Internet of Things technologies to build, I think, bigger experiences than the ones you're going to see standalone right now. Audio is also going to be one that's going to be really important. And you're starting to see that now with a lot of people focusing on always-on speech recognition, or at least keyword wake-up. So I'm going to talk for a little bit about an approach that we've taken, and I try to put it in a context. So about 4.5 years ago, we started thinking about how to help devices talk to each other. And the first time we really thought about the design problem, we thought about how do I make it so it's easier for a software developer to have their app interact with multiple cell phones. And at that time, those were the only devices we were considering, and that there was no Internet of Things terminology at that point. So I couldn't put a hashtag next to it. And we thought about what are the problems that we have to solve. Well, what are the problems that you do when you're trying to do any kind of application on the internet? What do you start with? First, you have to find other people to interact with, other services to interact with. On the internet, that's DNS, or maybe a protocol layered on top of DNS, the SRV part of DNS or something like that. In a proximal environment, there are things out there like UPnP, and there's MDNS and a couple other things. And we looked around and we really couldn't see something that had the performance characteristics and was designed that we thought it really had to work. So we started noodling on that problem. So you want to be able to identify things that are units of interactions, right? A way you could decide to do that is by having some architecture like have been in the past where you say, well, there are these things called devices, and there's these classes of devices, and class number 43 is a printer, and class number 44 is a scanner. And if I have a printer and a scanner together, then I have to make a new class, and you have all this stuff. We took a different approach. We thought that the unit of interaction, remember we were thinking about software people at the beginning, the unit of interaction is going to be the interface. So the thing you discover is an interface. So instead of saying, I'm looking for a printer, if anybody's old enough to remember AppleTalk, the way you would find a printer on AppleTalk is you would look for a thing of type printer, and anything that was of that type would return its name and a socket that you could talk to it over. In our system, we thought about we would like to be a little bit more fine-grained than that, and we would like it to be more like the internet. And in fact, even on the web API side of the world, there's starting to be a protocol for doing this kind of API discovery now. And we said, what if instead we said, tell me if you implement the printing interface, right? Because I don't need to actually know if you're a printer or not. I just need to know you speak the interface printer. So you can enumerate over the devices that are near you in this system and say who implements it. So I could have a TV that comes back and says, I implement the printing interface, send it a PDF, and it'll show up on the TV, and you have no idea that it didn't render it into physical little dots on a piece of paper, and you don't care, right? That's the way the internet works. We don't think about how the services are implemented. We only think of the APIs that we talk about. Now, we do have to take in consideration some other design principles that we really thought were important, like adapting to devices coming and going. So we had to build a mesh management protocol, and we did it in a way that was radio link independent. So we weren't trying to build a new radio. We were trying to build a system that could layer on radios that either existed or were going to be invented so that people can innovate in these two layers independently, right? Just like the web, just like the internet. We wanted interoperability across operating systems, and not only operating systems that were to what embedded people think of as big operating systems, you know, Linux and Windows and so forth, but actually little tiny RTOSes too. So we had to have a protocol that could actually be implemented on small little devices as well, because we didn't want to run different protocols for little things than for big things, right? Might be less functional or fewer services on these small things, but they shouldn't speak a different protocol, right? And we wanted there to be security from the beginning. So we wanted the primitives for security to both be there, but be extensible. So as both the ecosystem thought more about security, they could plug in new methods, and also it would, but from the beginning, that principle was in there. We took that idea and we really said, we started on phones, and we realized then that we could actually extend this to other devices around there and other things that were connected. And this especially happened after Qualcomm and Atheros got together, and we really started looking at the connectivity ecosystem differently. And we really changed sort of our behavior to start to think about the Internet of Things near me. And we say it that way, in particular in the team that I lead. It's just because of we're really trying to distinguish it from the cloud. And their class, wow, I'm really not happy with my automatic transitions. The cloud, not trying to say the cloud's bad, believe me, I'm actually trying to say the opposite. I'm saying that at the edges of the internet, there might be a new topology that we might need in order to gather bits of autonomous interactions and then perhaps interact with things that are on a macro scale. So think of it as I would like in my car, in my home, in my office to maybe have a mesh of things that communicate with each other, share intelligence, provide services in an aggregated way, but that doesn't mean they need to be on the public internet. And I might join and leave that mesh by my physical location and my physical proximity, and that's not to be confused with saying that I never want remote service or virtualized service, just that they're different, right? They have to coexist, but they don't have to be one or the other. Right? I don't need, for example, my Nest thermostat, I never set the temperature when I'm not at the house because I don't know who's home and how they would react to it, right? So my wife would probably be pretty mad if I pulled out my phone right now on stage and turned the heat on, right? I don't think that would go over real well. So I don't use that feature, but yet I like the fact that I can change the temperature from the sofa before we go upstairs to bed if it's a cold night and we had the thermostat set really low. So the Internet of Things near me is really dynamic, really oriented around proximity, and those circles of proximity could actually be different for different kinds of services application. I might have things in my room, my home, my car, my street, right? Those kinds of, my city, those kinds of things might matter, and we'll use different protocols for there, but we're really focusing on sort of what you can really reach with sort of local radiation of a radio signal. So there are a lot of things in there. The technology itself is called AllJoin, and it is a fully open source project that is actually not run by Qualcomm anymore. I'll show you what the organization that runs it right now. It's an alliance that the Linux Foundation runs. And our goal here is to say, in some ways, to answer the question, what is the HTTP of the Internet of Things? Right? So I will be the first one to admit that we probably didn't get it all right. And in fact, there are a bunch of other companies that have joined and are doing some interesting things. I think I'll show you that in a second. But the idea is to build something that actually is completely independent of operating system, radio. Even technically, it doesn't have to run on top of IP, although everybody that's using it now runs it on top of an IP transport. The first implementation we did of AllJoin actually ran over Bluetooth natively. We didn't see the need to put IP packet formats on top of the Bluetooth transport to do it. And what we're doing, we're starting to see an ecosystem. So LG makes a TV that actually speaks AllJoin and runs a service called the notification service, which is an open standard service on AllJoin. So you can actually send messages to these LG TVs and we'll pop them up just like notifications come up on your smartphone or on your desktop machine. So we saw a Kickstarter recently from the Super Mechanical guys, which is an MIT spin, that were doing a cool thermometer. And one of the use cases they had is that you have this thermometer out in your barbecue, and it says the food's done, and you're watching TV. It'll use AllJoyn to send the message, and it'll show up on any brand of TV that implements AllJoyn. Happens that LG is the first one, so that was kind of cool to see. So a lot of people have joined and are thinking about new kinds of services on top of that. Let me show you something real quick, something I think is really cool, since this is a chip conference. So what you're looking at here is actually a module from a company called Li-Fi Labs. They make a consumer-facing light bulb, the LifeX light bulb. But this is actually a Wi-Fi chip and an MCU and a bunch of the other circuitry to control LED lights through PWM interfaces. And that is a module that not only LifeX is going to use to do commercial bulbs, but they're also going to license to other people to put in their LED bulbs. And it runs an open source, interoperable control protocol. So you could have light bulbs, connected light bulbs, from 5 different brands, all talking the same protocol. And then interesting things happen. I could then go into the Play Store or the App Store, or whatever store there will be 5 years from now when these light bulbs will still be in my house, and I could get experiences that have been curated by application developers, one of which probably matches the way that I think about lighting, one of which maps the way that you think about lighting. But I don't have to worry about the fact that, is the company going to still be in business? Is this protocol going to still be around because it's an open protocol implemented on top of open standards? So I thought that to me is the beginnings of that. So there's going to be some more announcements about that kind of stuff, I think, in the IFA or in the fall timeframe, but they've already announced the availability of the module. And the Wi-Fi chip is something we've had for a while. So I'm going to stop there. I will put up I don't want to do that slide. We talked about all that. I will put up the slide on the Alliance. So if you're interested in more about the protocol and the ecosystem, there are about 60 companies that are already in the Alliance. It's allseenalliance.org, or you can go to the GitHub repository and get the code and check it out. If you see something that you think you can do better, please contribute it, join the club, and fix it, and hopefully we can make something cool happen around the Internet of Things. And with that, I will take questions. Are you going to drive the question? I think there's some mics somewhere there. Yep.
Yeah, John Massey, TechVisor. Quick question. Technology always gets ahead of legal issues. Do you guys talk to lawyers about privacy and stuff like that, like Pam Samuelson at UC Berkeley?
We do. First of all, you're asking a guy at Qualcomm if he talks to lawyers. I talk to lawyers way more than I want to talk to lawyers.
No, but I don't. There's different flavors of lawyers. I mean, the ones that worry about, that are techie and worry about the intersections with law. And
absolutely. I mean, now, have I sat down with Lawrence Lessig and talked about this? No, I haven't. But I will tell you that we actually tried to design a topology that is actually enforces security and privacy by design. So, for example, the way, by default, AllJoyn talks to other nodes on AllJoyn, it doesn't use publicly routable IP addresses. In fact, explicitly doesn't. Because in my view, if I'm going to have several hundred of these devices talking on a mesh at my house or in my car or my home, I want the default behavior to be private. And you have to do something special for it to be out. So the best way we know to do that is to implement it that way out of the box. Can you do something that would violate that privacy? Yes, but like a lot of people in the field, I don't confuse encryption with privacy or security. So for us, it was we tried to follow a design principle that is actually very hardware-driven, which is locality of reference, right? If I don't need the data to go anywhere further than this, don't send it, right? And that's something very, very different than a lot of, right now, people who come up through school writing, Android applications think, oh, it's free to just throw stuff into the cloud. Well, it's not free. There are implications to it. And so we tried to design the core of it from the beginning to make it easier to be private and secure than it is to not. That's about probably the best we can do in an implementation. And maybe later on, the specs and the standards around it that the Alliance is trying to put around it for compliance and trademark and stuff like that, will enforce those through either contractual or licensing rights.
Next question, please.
Bernard Xiang, MediaTek. So can you comment on the IPR policy of AllJoyn or Allseen? In other words, open source does not equal to never need to pay, say, patent or license fee.
So yeah, Well, I can point to a blog post where I publicly say that Qualcomm will never monetize what's going on in all-join. Is that enough? Okay, thank you. I know where that question's coming from too, by the way.
This side, please.
I'm Mike Berzoni with Camp Marketing. One, I would be interested in any more thoughts you have on social responsibilities and social industrial responsibilities as you just provided to Mr. Massey. Also, in the car example, because cars are typically validated during development in the terms of 400,000 hours or so, and then upon their release see an exponential amount of use and glitches show up. Do you believe that what you're proposing from the standpoint of wireless interfaces in cars or any other forms of novel technologies will expose themselves to more government scrutiny in the validation process pursuant to the implementation of these systems in vehicles?
Okay, I'm not exactly sure about what to say about the social stuff, so maybe you can clarify that in a second, but let me answer the second part of the question first. In the automotive space, most of the stuff I was talking about, I would consider to be on the infotainment side of the bus for starters. So I think you're going to be looking there about just changing the experience of the car, and that might have to do with how navigation happens, but I'm not actually standing here and arguing that we should be using all-join to control the brakes. I understand what that means. I do think, though, that we're in a weird, or an interesting place, I should say interesting, not weird, where we could decide as an industry to just basically say we're going to have these vertical solutions, or we could do, and we'll end up with AOL and CompuServe and Prodigy in industries like automotive, or we can say there's an open ecosystem and let's see what happens, and that's kind of the main point I was trying to make. Not that I'm going to be oblivious to safety or anything like that. Yeah, there are parts of the car that it really matters and have those those test constraints that you have. And there are parts of the car like the tape. Sorry, I'm old. I said tape player. Like the music player that don't have to have that same thing. Yeah, they need to work when it's 100 degrees in the car, but that's more like I don't want you bringing back the radio because it got to be 100 degrees, and that's different than safety. So anyway, what was the social thing? I didn't.
Perhaps old or tenured and wise, I appreciated the comment about regulating the use of your audio equipment in your car pursuant to the analogy of the child you did not know. I also respect your description of social responsibility associated with keeping data where it's needed and not where it's needed. So from the standpoint of the sociologist in you, which there obviously is, what other aspects of social responsibility do you see? If you could provide one or two more examples that come to top of mind, I just thought they were fascinating.
I don't know, we're doing a lot of thinking, we're working with UI people, and I would say I'm thinking more about the consumer. You asked for something about industrial, and I'm afraid I'm going to bow out of that one because that's a whole nother bailiwick. So things like in my home, not in my home, in a room, not in my room, those are the ones we mostly come up with. We've thought about also systems that infer things about relationships because you at one point were proximal. So for example, we have been near each other a lot. We might discover that, and then either by generating a key pair or when we're in proximity in a way that could only happen in proximity, we might be able to then have a different kind of relationship when we are virtualized. So that's about the area that we've sort of bounded it by.
Next question.
Bob Masley at Oracle.
Hey.
Rob, have you considered the personal medical, for example, where you have a blood sugar monitor communicating by protocol to an insulin pump patent issued this year?
Okay, I'm not sure what to do with the statement about the patent being issued, but
clearly communicating, oh, yeah, never mind the patent, but that's just a state of the level of development. That
right.
would be personal in scope, obviously a high level of dependability and security would be required, and it's definitely local.
Right, so the stuff I was talking about, I'm not actually trying to make a statement about reliability or availability, or in fact, in all honesty, about security, because for each application you would use different mechanisms for that. I was merely describing a system. My thought in that area would be that I wouldn't want to build a bespoke protocol just for those two things to talk to each other, because I don't know what other things are going to come in 2 years and how I might want them to interact. So I think it's interesting to think about an environment where you can discover, enumerate, introspect about services that are needed, whether it be on a personal network, or on my body, the room I'm in, or so forth. And then on top of that, layer the appropriate credential management, authentication, identity management kind of system. So if I want to talk to my insulin pump, I better know who the heck you are on the other side of it, right? But that doesn't mean that I might not also want this band that measured my steps to maybe advise the insulin pump, and that doesn't have to be nearly the same connection, secure connection, because the insulin pump could act on that data or not, right?
Yeah,
so there's this blend of consumer and sort of HIPAA-compliant medical stuff that I don't think we have I don't have a rote solution for.
No, but clearly there's a benefit in all joint because, for example, a patient might want the control algorithm to be strictly local, but might want it continuously communicated to their doctor for their medical history.
Absolutely. Agreed. Thank you.
Next question from here.
So my question is kind of open-ended.
Where are you from?
I'm from AMD. My name is Trivikram. So email has been around for more than 20 years. And still, the email that I use is hosted out of a server that I've never seen, even though there are multiple boxes in my house that are perfectly capable of being a mail server. And I think that's true of most people here. Why do you think that is?
I think usually that's because of availability and reliability. If you want to be your own IT support guy, you can run your own email server. There's actually nothing stopping you to do that. That's why there's so much spam on the internet, is that there's no authentication in SMTP.
So why can't all those services be provided as a product that I could go buy? Why should I trust people that I've never seen?
I don't have an answer for that question. You can. There's nothing stopping you from doing that. So honestly, there isn't. I could run a mail server at my house if I wanted to.
Well, but you touched upon those issues. It's
yeah,
difficult to maintain.
So I just think email is a very different thing, right? So I'm saying that as we build out collections of things that are going to expose services through interfaces to each other, that there's going to be interesting things that will happen locally. Email is a global interoperable standard, so whether you instantiate that locally or virtualized has very little bearing on how it works as a protocol, right? So that's the only point I was trying to make. So I think it's one of the reasons to do protocols like AllJoin is because you might want to build a very private system that only works amongst itself. If you want that to go out onto the public internet, like email, which is its utility is because of how all the people you can talk to, then you're going to have to deal with that side of the problem, and I am not speaking to that problem with AllJoin.
Okay, last question.
Okay, thank you for sharing your insight. The question here is, most of people so far only talked about something related to personal needs on the Internet of Everything. However, on the other hand, we also have the critical infrastructure ranging from the power grid to regional anti-missile Iron Dome. So all these things eventually, I mean, for example, like the previous question touched upon the insulin pump. I mean, that could also be a critical infrastructure for the patient, right?
Yeah.
So do you see the industry will have some kind of a convergence? Because one side claims that's for commercial Internet of Things, the other side says that's for the industrial Internet of Things. Well, they're all Internet of Things, but different flavor.
Yeah. I completely understand the question, and by the way, it's one of my least favorite things about this name, the Internet of Things, is that all of a sudden everybody said, well, if it isn't a web server, it's an Internet of Things device. And the industrial Internet of Things, when GE talks about sucking sensor data at terabytes per minute out of a jet engine that they're going to do analytics on, that's not the same thing as talking to your refrigerator, right? And if you want to call that the Internet of Things, that's fine. I just call it the Internet, and I think there are different use cases. So a lot of the industrial Internet of Things is about sensing and aggregation of data, reduction of data at local endpoints so that you can actually deal with it, and then machine learning in the cloud. I don't have a problem with people calling it the Internet of Things, but it isn't the same thing as the consumer. I call this the consumer Internet of Things, for lack of a better word. So I think it's unfortunate that we're labeling it that way because I think it's confusing, but terminology will shake out. I think it's going to work itself out in time.
Thank you.
Thank you.
Thank you so much. Let's thank the speaker again. And